So hey everyone, welcome to the first Gremlin office hours. Today we'll be focusing on how to find and test critical dependencies. Thanks so much for joining today. Just some quick notes before we get started. This is an interactive webinar. We do want to hear from you as much as you'd like to hear from us. So please feel free to enter any questions into the Q&A panel. Also, this webinar will be recorded and the recording will be made available after the webinar. I just saw a question come in about that. We will have that recording sent out afterwards and also available on demand for any folks who might have missed this session. And also, office hours will be a monthly series. Next month, we'll be focusing on Kubernetes reliability. So if you're interested, we'll have a sign-up link available at gremlin.com/office hours, the same way you sign up for this webinar. You can head over to that, check out our upcoming sessions and upcoming topics, and sign up for those through there. And also, just to introduce myself real quick, I'm Andre Newman, Senior Reliability Specialist, and I'm joined by Dan Moret, Senior Solutions Architect here at Gremlin. We're here to answer your questions, so definitely don't be shy. So a quick overview of what we'll be going over today. I'll start with just a short presentation introducing the topic. I'll do a really quick overview of the process that Gremlin uses to detect and track dependencies for you. Dan will run us through a demo showing how to test these dependencies in Gremlin and how it works as if you were using it yourself. And then we'll leave time at the end for Q&A. Again, we're here to answer your questions. Please feel free to drop them into the Q&A section. This includes requests if you want to see a particular part of the product or you want us to cover a topic over again. Please don't be shy. So first, let's set some goals for today's session. At the end of the session, we want to create a list of dependencies belonging to each of our services that we can track. We want to be able to run tests to simulate slow or failed dependencies and make sure that our services can tolerate these situations. This includes checking dependencies for expiring TLS certificates. And then we also want to automate this testing so that we can catch and prevent regressions. But even more important than that, we want to know what your goals are. What are you hoping to get out of the session? What issues are you running into or that you have run into that are related to dependency discovery or even anything else around reliability? Definitely let us know. So to jump right into the topic, this slide is mostly for level setting. If you've joined the session, chances are you already know what dependency is. But just in case, just so we're all on the same playing field, dependencies are any sort of independent service that adds feature or functionality to another service. And dependencies are everywhere. They can be other services run by other teams in our organizations. They can be externally hosted services like AWS. And of course, your services can be dependencies of other services. And that's when reliability becomes really important, right? It's when somebody's knocking on your door or sending you a Slack asking why your service is down because it's impacting their services. And when you look at the dependency chart for an entire application, what you end up with something very similar to the chart on the right, with all these interconnections between all these different services and one thing depending on another, which depends on another thing. And while this chart might look pretty simple, the problem is that as we outsource more and more functionality to dependencies, this chart becomes more and more confusing and more convoluted. And what you end up with are these, what we call microservice death balls, which are just these enormous, unreadable masses of different services and different interconnections between them. And granted, not everyone is at Amazon or Netflix's scale, but even if you have half of these services, it's still way too complex, right? No single person's mental model can keep track of all of this. So really what we need is a system to be able to track this that's more advanced than something like a spreadsheet or some sort of manual tracking tool like that, but also makes it very clear about what dependencies our service is reliable for or reliable on, and ensuring that our services can keep running even if those dependencies are unavailable or if they're going through incident. So when we talk about dependency tracking and Gremlin specifically, there are three key concepts that we want to consider. First is services. Gremlin associates dependencies to services. So the first step is defining these services in Gremlin, either manually or by letting us automatically detect them. And a service can be anything like an application running on a host or a Kubernetes deployment, basically some software component that your team is responsible for. Once we have those, Gremlin auto-detects the dependencies that our service talks to. And we do this by checking DNS queries that the service makes. You can also manually add dependencies yourself, and Gremlin will recommend dependencies if it's not 100% confident that they are dependencies, just so you can review them and add them yourself. And after this, once we have our services and our dependencies detected, Gremlin will automatically create tests that you can then run on these dependencies. These include latency tests, failure test, and also TLS expiration tests to make sure that your service can keep functioning even if one of your dependencies fails, if their certificate in the chain becomes or is expiring soon, or if there's a slow network connection between them. And one important note I would like to add here is that when we say Gremlin runs a dependency test or running a test on a dependency, what we're actually doing is we're testing the service itself. We're testing the connection between the service and the dependency. All of this happens on the service where the agent is running. So it's our service that experiences latency, our service that loses connection, and that gets its certificate chain inspected. This is how we're able to do things like run dependency tests on AWS services or on other managed cloud services. You can imagine AWS wouldn't be terribly thrilled about the idea of us shutting down an entire region to test a single service, but this lets us achieve the exact same result and have it also be fully under our control. So just keep that perspective in mind as we talk about dependency testing. So looking at it a bit more in detail, the way this works is you start with your service. Like I mentioned, this is the part of the application that you'd like to make more reliable. Importantly, this is also where Gremlin is installed. So that little logo at the bottom represents the Gremlin agent running alongside your service. And as your service communicates with other services, like databases, let's say scripts or applications, web servers, load balancers, whatever it might be, the Gremlin agent looks at DNS queries and network traffic between your service and the dependency. And if the agent notices a lot of connections to a particular service, it identifies it as a dependency. The more connections it makes, the more confident Gremlin is. This helps prevent one-off or infrequent requests from being listed. So for example, if you rely on the network time protocol or NTP, that won't show up as a dependency because it's kind of a given, right? We're looking for things that are unique and that you communicate with frequently. And because this process is DNS-based, we can track dependencies by their host name. And this is important for letting us support dependencies with changing IP addresses. So something behind a load balancer or something behind an API gateway where you're not really sure what the IP address might be, we're able to track that without losing information or losing track of it. And with that information, Gremlin sends this data back to our backend systems where it then shows up in our web UI. So that way you can review your dependencies, you can see them next to your services, and of course, click on them for testing. And even though a lot of this is automatic, you can still always add dependencies yourself and edit or remove existing ones. And one really nice benefit that we actually discovered ourselves at Gremlin is that this is really helpful for finding hidden dependencies or dependencies that you might not have known about or forgot or never got around to documenting or was part of your environment for a test and it just happened to remain there. So we don't just do dependency testing, but also dependency discovery and tracking. And as a fun fact, when our engineering team was trying this feature out, we actually found some of our own hidden dependencies lurking around. So not only did we eat our own dog food, but we actually got something out of it as well. And so with all that in mind, I'm going to turn it over to Dan, who's going to run through a demo of dependencies.
Thanks, Andre. Start share. So just to kind of highlight or show what those dependencies look like inside of Gremlin, once we add a service, so this is a sample open telemetry application, and just to kind of show high-level architecture of what that looks like. This is the architecture map for this. So it's a little bit more complex than Andre showed for the online boutique. Just kind of goes to show that, you know, even a sample demo app can get a little confusing. There's multiple different languages here. There's different dependencies that we have. So we'll look primarily at this front end service just because it has the most dependencies. So we can kind of see how this maps to payment service, ad service, all of that kind of good stuff. So we switch back to Gremlin. I've added the front end service to my Gremlin instance. I have my Gremlin agent running alongside my demo application through the typical agent installed using Helm. And if we scroll down here, we have dependencies. So we can see that my front end service that I'm targeting shows all my different dependencies. So I see that I'm talking to my cart service, I'm talking to shipping service, I'm talking to payment services, ad services, currency services. All those different dependencies are different components that my front end service is talking to. And because of the traffic that Gremlin agent is seeing, we've added all of these automatically. If we click into the dependencies, we can see each of the dependencies listed, each section here, and you'll see the failure test, latency test, and certificate expiration test that we run on these. We can click on any of these, see the results of that, see what is done. You can also manually add dependencies. So if for some reason you maybe have an infrequent call or something that is a dependency that you know about that maybe we haven't detected or we haven't caught yet, you can add those dependencies through here. So you can come in and just to kind of highlight this, right? I can say, okay, maybe I have a dependency on Amazon. So if I add, I just give it a name, and then I can give it a name port. So you can do this by multiple different ways, right? You can, it's documented here, but you can add it by IP address, host name, ports, all that kind of stuff. We'll just put in aws.amazon.com. And so we can save this dependency. This will now be added as a dependency to our service and be tested just like all the other dependencies. So if I go back into my dependencies, here's Amazon, so it shows up. And of course, since I just added it, none of these tests have been ran. We can kick any of these tests off and it'll run the same test. So again, this is testing the connection from my front end service to, in this case, Amazon, but it's really the same concept of just blocking network traffic to these. So what happens if I black hole a dependency? What happens if there's a latency? Default is we add 100 milliseconds of latency per packet. So that's completely adjustable through the test suites functionality. And then the certificate expiration, it basically will try to make a secure connection to the dependency. If it makes that connection, it'll try to pull your certificate chain, and basically it'll come back and tell you if your certificate will expire within the next 30 days. So that gives you just a high level overview of kind of how dependencies work. If for some reason you have a dependency that it's like, okay, I know that's a dependency, I don't really want to test that one, right? You can come in, hit the little gear icon, you can edit these, you can delete these dependencies, that sort of thing as well. So you can kind of customize this to really tailor to your environment. So with that, that's the high level overview of kind of how dependencies show up, how to manually add a dependency. So we'll open it up to any questions, whether it's around dependencies or anything else Gremlin related.
So we had one question come in already. How would this map to something like AWS RDS?
Yeah, so I can take that one. So it'll show up just like these that I'm showing here on my demo environment. So you'll see that RDS connection show up here. So we can add and apply the same type of test. So you can run a failure test, a latency test, and certificate expiration against an RDS source. Certificate expiration, like I said, if it doesn't have a certificate chain, and it can connect, it'll pass just because there's not a certificate there to test. But you should be able to test the failure and latency test. So again, kind of keep in mind that this is testing the latency and the availability of a dependency for your front end service. So your service itself is this front end service in this case is really what we're monitoring. So we're monitoring, does the latency, error rate, response time for my front end slow down, stop, increase because of a latency issue. So that's really what we're trying to engineer and make sure that we're accounting for latency and things like that of those. But it doesn't matter if it's an RDS, if you're connecting from a cloud-based front end to a SQL server that maybe is running an on-prem data center. Doesn't really matter as long as there's a connection there and traffic flowing to that. We should see those, and those should automatically be detected.
Cool. Thanks for that question. Again, if you have any questions at all, don't be shy. Feel free to post them into chat or into the Q&A pane. We're here to answer any questions you have. All right, so we had another one come through. For latency, is there a way to develop an accurate network profile between the service and the dependency as compared to using a fixed value? Is that one you want to take, Dan, or should I?
I'm still trying to figure out what is really being asked there. So yeah, if you get it, go for it.
So what I think is being asked, and feel free to correct me on this if I get this wrong, is there a way to vary the amount of latency between the service and the dependency as opposed to just adding like a specific amount? The way Gremlin works now, we only allow you to enter a specific amount during an experiment. So you can add 10 milliseconds, 50, 100 milliseconds, up to, I think, 2 full seconds. But what you can do is we have a feature called scenarios, which lets you link multiple different experiments together. So you could have a latency scenario that for maybe 1 minute, it adds 50 milliseconds. Then for the next minute, increases that to 100. And maybe for a minute after that, increases that to 500 or however high you'd like to go. So again, within an experiment, it's fixed, but you can vary it to add as much latency as you would like. So I hope that answered your question.
Looks like Dell has another question about a marketplace of sorts for various services offered. So when you set up a new experiment inside of Gremlin, so this isn't necessarily related to dependencies as we kind of showed them through services, but through like experiments, you can, let me see here, demo, we'll pick an ad service. And then when I get down into choosing a Gremlin and I want to run a black hole, for example, if you look at this field here called providers, so on the back end, we uh, get or pull information from AWS and Amazon. So for example, if I have a dependency or I want to, or I know that I have a AWS S3 bucket, so I can, through here, I can type in AWS S3, and then I can pick the region that my bucket lives in. So maybe I am in AWS S3, US East 1, and this will block access to AWS S3 in US East 1. So that's kind of where we pull in those providers. If you're using these, then the dependencies should show those and pick those up. If for some reason it doesn't, or you want to test that another way through experiments, this is kind of where those provider tags or that catalog is kept, is through here. So you can block everything from Azure AD to all the AWS services, whatever you happen to be using there. Most of those are listed in here for you. Gremlin support legacy Windows services. So the dependency discovery today works on Linux and Kubernetes primarily. We're working on getting that done for Windows. It's a little bit different process just because of the architecture, the kernels, and all that kind of good stuff. So that is being worked on today. That's on the roadmap, I believe, for later this quarter or early next quarter. So that is becoming, so today you can manually add a legacy Windows service. You can run all the experiments you want and things like that against a legacy Windows service. We just don't auto detect those dependencies. You have to manually add those today until we get that piece out for Windows. And then let's see, James. Hey, James, how's it going? Does the service have to be defined on the application level? Doesn't have to be. It can really be any level that makes sense for your environment. Like for example, I added a service for this front end. If I switch back to this architecture, I added this front end service and we see all these different pieces, but maybe my checkout service or payment service has got other dependencies underneath that, right? So I might want to add my payment service to run the same type of test, CPU, memory, those sorts of thing on that service and its dependencies. So it's really kind of a one level thing. So you want to, target this maybe at different levels. But on the other hand, if it's a very simple application, kind of like the one that Andre showed on the slides, maybe just doing it, for the entire application works fine. So that's something that, if you have something like this, an architecture diagram, happy to kind of work with you on how to best set those type of tests up. Okay, can we run EC2 and EKS black hole tests in parallel? Well, where EKE is hosted by the same EC2 instance. Yeah, Harin, on your question about the EC2 and EKS black hole test. So generally speaking, you can't run multiple network tests or experiments at the same time on the same network adapter. So if these are different environments, you can run the test at the same time. That shouldn't be an issue. You can set that up through scenarios, adding different, black hole scenarios for the different target host or infrastructure components. So one in EC2, one in EKS, and be able to do that. So as long as they're not sharing the same network adapter, you can run multiple experiments, either serial or parallel.
And we did have a question coming through the Q&A pane. What strategy does Gremlin have for validating or analyzing application logs during the experiments and scenarios? So the way Gremlin works is that we are able to monitor your systems during an experiment using a feature called a health check. It basically goes out, it pings a endpoint that you provide. This can be a monitor, an alert, even just a URL, like your application's front end. And depending on the response we get back from that, whether it's a pass or fail, or if it takes too long to respond, we determine whether or not the experiment passes or fails as sort of a reflection of the health of your service. So while we can't read application logs directly, you can set it up to where, let's say you have a alert or a metric that monitors your application logs in your observability tool. Then Gremlin connects to that monitor or alert, and based off of whether it fires or not, we're able to tell whether or not your systems are healthy or potentially down. So that's typically how we recommend monitoring your systems while you have an experiment going.
And I've answered a couple other in the chat. Mainframe. So mainframe, we don't have an agent for the mainframe. It's just not used enough, and it's complicated enough that we just haven't had the need to or the demand to make the agent for a mainframe. But you can treat the mainframe as a dependency, or the mainframe services that is the dependency. So if you have an application that's maybe on cloud, Kubernetes, Linux or Windows, application server that then connects to the mainframe on the back end. You can add latency or block traffic going to that mainframe to test and see how that works. Very similar to how you would handle like an RDS or some other sort of remote connection. And then let's see, ECS. Yes, you can run Gremlin in ECS. So there's documentation on how to install that. Any of the Gremlin essays can also help you get the Gremlin agent installed in that ECS environment and do this test. How to add a health check in scenario for EKS test. So while I'm sharing, so if I create just a new scenario, this is the blank default template by default. So we'll call this one webinar, just so I remember to come back and delete it. We'll add a show health check and scenario, and then you add a health check. So basically you can define your health checks through the health checks tab, and then once those are added, you can come in here to health check or to the scenario creation screen, add a health check, and then this will pull down. I've only got a couple of health checks. This is a new environment, so I can add a couple of, here's a front end in Grafana, and then a CPU increase that I'm kind of testing. So if I add this front end for Grafana, update the scenario, that health check pulls into my scenario, and then I can add my test. So I can create a new test or add a completed test, whatever the case may be. And then as I execute this, the health check will be evaluated first, make sure that your application is healthy. So for this question, make sure your EKS node or cluster is healthy. Assuming that comes back with a return code 200 or a green, we'll get the go ahead. Then we'll go through and start running the test. So whether this is ordered nodes and we're running these sequentially, or we're adding this and running tests in parallel, doesn't really matter. As long as this passes, we'll start running the test, and then we'll continue to check the health check while the tests are progressing. And at any point, if your health check fails, the test will be halted and roll back, very similar to the behavior through services. But that's how you add the health check inside of the scenario.
And one thing to add to that, like Dan mentioned, when you add it under health checks, that runs continuously, or it checks it before starting the scenario, then checks it continuously. You can also add one-off health checks by going under ordered nodes, the same way that you would add a test. And this is a point in time at that stage, it will run that health check, make sure your systems are up, and then it will continue. And that's just a really good way of just before you start the next stage in your experiment and you don't want to run a continuous health check for whatever reason it might be, you can use this technique too. Right, so maybe you're
Yeah, so
running a
to illustrate
certificate.
that, yeah.
Sorry.
Yep.
Yeah, so if you're like about to run a certificate expiry test, you can add a health check real quick just to make sure that that service or dependency is available, and then go on to run the test, just as an example.
Yeah, no idea why you would ever do this, but that's just what I happen to have in the demo environment. Yes, the tests will stop if a health check fails. So in this example, if either of these fail and we get back anything other than a return code 200 or a healthy, or whatever your APM happens to respond with, it will halt the scenario, and any test running will be stopped. So you'll get a halted, and you'll get a notification saying that it was halted because the health check failed.
Lots of great questions. So we'll give it another minute or so. If you have any other questions you'd like to submit, feel free to do so. If you'd like to see any other part of the product, or if you have a question about something that we covered, we'd be happy to do that as well. That's an interesting one. So let's say we want the health check to fail and still pass the test. Can we opt in for that if you're testing a monitoring scenario? Dan, would you like to take that one?
Yeah, so the evaluation for the health checks are simple pass fail today. So there are ways so you could set up a scenario, run the scenario. So you want to test your CPU or disk space monitors, right? So you can just run that scenario and then just watch the alerts, make sure they fire, make sure they trigger, that sort of thing. So there's ways to do that, but from the Gremlin perspective, when you integrate that health check, that serves as a gate or a mechanism to keep us from impacting the services. So if we get a backup fail, this test will be halted. Yeah, okay. So build and run tests in parallel. For example, run a black hole in CPU to run in parallel. So to do that, you add what is called a concurrent node. So this allows us to add multiple tests. So I can go in here then and define a CPU test and a black hole test, or maybe a CPU and a latency, or whatever those are. So from these, I can come in, add node. So I can maybe add a new test. Let's do Kubernetes. We'll pick my ad service for a target here. And so we'll do network, black hole, update scenario. And then I can add a secondary test. So maybe I come into the same thing, add service. And then this one maybe is a resource CPU test. It's going to run CPU test at 80% to keep it from being killed. Update scenario. So now when I run this scenario, if I were to save this and run it, it would run these two at the same time.
We do
Let's
also
switch
have the ability.
teams.
Oh,
Oh, go
sorry.
ahead.
Say we do also have the ability to switch from sequential to branching, I believe, within the same scenario. So if you do want to
Yeah,
run
you
one
can run
test up
both.
front and then run two after that, you can do that.
I had that exact question set up in a different account. So this one, my health check failed. So this one checks the health check, but then you can see the branch is here, CPU and memory. And so this actually illustrates the point the health check failed, so the test never even kicked off, right? Because um, I don't know, I may or may not even have the agents installed for Datadog anymore in this cluster. But this is a good illustration of how to set it up, but then also what happens if that health check fails. So my health check failed. I get a failed message on that. So then my test didn't even complete. So if I wanted to run these anyway, I can just remove the health check from the scenario and the CPU memory test would run. But if that health check is there, it is a gate to allow the experiments to run.
So one good question that just came up, did the earlier recording show auto-creating Gremlin tests based off of auto-discovery of dependencies? So as soon as Gremlin detects your dependencies and it connects it to that service, the tests are already made available. Those tests are pulled from what we call a test suite, which are just a collection of tests that are, um, by default, they are automatically baked into what we call Gremlin recommended tests. These are the exact same thing as scenarios. You can actually find these scenarios and run them yourself if you want to. We just list the scenarios by category and have them contribute to overall score that applies to each of your services. You can actually replace all of these with your own custom scenarios or your own custom test suite. So you can create your own sort of evaluation criteria for your services. And so based off of this is how Gremlin determines which test to add or to create for each dependency. And it's all done automatically as soon as the dependency gets added.
And to kind of show that the dependency I added kind of earlier during the demo. Um, let's see here. Oh, let me switch back to my test team. So the dependency I added earlier, just for Amazon. So I added the dependency and it automatically says, okay, this is the dependency. We're going to automatically add the tests that are part of the test suite. So because these are the 3 tests for the test suite for dependencies, they're automatically added and they're ready to run. So I kicked off the failure test during the demo. We can kick off this one and it'll run the latency test as well. But that's these are all, so whether you add a dependency manually or Gremlin detects a new dependency, it'll automatically get assigned the test that you have for dependencies, and it'll automatically run those next time you run the test. So
Any other questions? All right. Well, it doesn't seem like it. So just to wrap up, I'd just like to switch back to the slides real quick, just to give you all some next steps and additional information if you would like it. And of course, I just completely lost everything that I had open because Zoom reflowed my windows. Just give me one moment.
you're showing your demo and Q&A slide if that helps.
Yep. I had a presenter view off to the side that just got completely buried. All right, there we go. So thanks for bearing with me. So there are 2 ways that you can get started. First, if you're already a customer, feel free to jump into the product. You should already have access to this. If not, you can get a free trial at gremlin.com/trial. If you don't see services or dependencies in your account, feel free to reach out to your Gremlin admin or account rep and we'll get you set up. If you found this valuable, or if you just enjoyed this webinar and like to join additional ones, we'd love to see you in one of our upcoming office hour sessions. Again, this is going to be a monthly program. So you can see the next topics that we're going to have available and also sign up for them at gremlin.com/office hours. And we'll, of course, be gradually updating that page as we add more sessions and as we finish ones like this. We'll be posting on-demand recordings as well. In the meantime, thank you so much for joining us. Hope this session was helpful for you. If you have any additional questions after the webinar, please feel free to reach out to us and we'll be sure to give you an answer on that. In the meantime, thanks again for joining us and have a great Wednesday.